So if we're going to graph this equation, first step is
Make a table.
no.
Graph.
No. Solve for y, that hidden direction. Now I know the book doesn't do it that way, but I highly suggest that you do it. It makes your life a lot, well, easier. So if you solve for y, you get negative 3y equals 4x plus 6.
That's
And then
negative 4.
no, you're going to add it over to the
Oh,
other
yeah,
side.
that's right.
It'll be positive 4. Then you divide everything by
3.
negative 3. Well, you don't like saying negative or something? I think it's negative. Then you get y equals negative 4/3 x minus 2. Now you do a table. Then you set up a table. Here's x, here's y, independent variable, dependent variable, negative 4/3 x minus 2 will go up here, and you pick a bunch of numbers. What number do you want to pick?
3.
3. Negative 4/3 of 3 minus 2. Now the 3's are going to cancel. You're going to get negative 4 minus 2, which is
6.
is negative 6, which is a fine point. What other number you want to try?
0.
0. Usually works nicely. Negative 4/3 of 0, of course, is 0. 0 minus 2 is negative 2. Last number?
Negative 3.
Negative 3. I usually start with negatives and then work, but you know, whatever. Negative 4/3 times negative 3 minus 2. Now, 3 goes into negative 3.
Negative 1.
Negative 1 times negative 4.
4.
Positive 4 minus 2. 2. And then you know, do a little plot. 1, 2, 3, 4, 5. Where's the 6? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4. Where's 3, negative 6?
Right 3.
Right 3?
Down 6.
Down 6. And then 0, negative 2?
Down 2.
Down 2. And then negative 3, 2?
Right 3. Left 3, I'm sorry.
Left 3?
Up 2.
Up 2. And hopefully, hey, that actually lined up very well. There's your line. What kind of slope does it have?
Negative.
Negative. Decreasing. That's about all you can say about it. All right. So today's stuff? No other major questions? Oh, you have a major question. What?
Let's do.
Is it like this one?
No.
Okay.
Let's do number 9 on 3-2.
All right. What's it say?
3/4, comma, 4, parentheses, and negative 2, comma 0.
What am I looking for? Is it just slope, or is it perpendicular slope, or is it parallel slope?
This is slope.
Just the slope. All right. So subtract the y's first. So you're going to get 4 minus 0 over, subtract the x's next, and you're going to get 3/4 minus a negative 2. Make sure when you do that minus, especially if the number is negative, put it in parentheses. It keeps you safe from sign mistakes. All right, 4 minus 0, of course, is 4. What's 3/4 minus a negative 2 become? 3/4 plus 2. How do you want to write the 2, though? Well, it's going to be 2 over 1. And to get the 4 in the bottom, you're going to have to multiply top and bottom by 4. So it's going to be 8.
Over 4.
8 over 4. So what's 3/4 plus 8/4? 11/4. So we're going to have 11/4 down here. How do you divide a number by a fraction?
You
4 over 1 divided by 4.
change flip
Change flip. Okay, I'll go with that. So what do I write?
4 times
4 times
4 over 11.
4 over 11. So that becomes
8 11. 16 11.
16 11s. Multiply straight across the top and bottom. So there's your slope. Now, is there another way of doing this?
Sure there is.
Yeah, a lot easier too. The easier way, again, the book doesn't show you this, and we've already really done it. If you have 4 minus 0 over 3/4 minus 2, you can treat this like an equation. Equations have a left and a right. Fractions have a top and a bottom. And whatever you do to the top, you do the same thing to the bottom. So what did we do with equations that had fractions?
Find those LCD.
Find the common denominator. Okay. And multiply by it. What's the common denominator?
4.
4. So I'm going to take the entire top, do a different color, and multiply it by 4. Take the entire bottom, multiply it by 4. The top becomes 16. Here you're going to have 4 cancels out, and you're going to get 3 minus 4 times 2? 8. So this becomes, negative 2. This is plus. So it'd be 3 plus 8. And you get 16 11ths. It's a lot quicker, I think. Multiply the top and bottom by the common denominator. It gets rid of the fractions top and bottom. Numerator and denominator. Anything else? All right. 3, 3. Three is a very long section. There's a lot of little detail to it, so I'm going to have to be very careful how speedy I go. So 3, 3. What do they title it as?
Graph and the equations of line.
Equations of lines. Let's call it that. Equations of lines. While we're here, let's do a little review. We have actually dealt with 2 types of equations of lines. Things like x equals 3. How do you graph x equals 3? That's an equation of a line. What's it look like? Is it horizontal? Is it vertical? Is it slanted? Does it have positive slope? Does it have negative slope? Does it have 0 slope? What is it?
It's horizontal.
It is not.
It's vertical.
It is vertical. Why? Because it hits the x-axis at 3. Now, if it's going to hit the x-axis at 3, if it goes horizontal, it's going to have a lot of different x values, but x is fixed to be 3. So this line is going to be vertical. So these are equations of lines that you have to be able to figure out. Now, second question. What's the slope of the line?
3.
0.
Whatever, this is between your points, huh?
Yeah.
The slope of the line. Is the slope positive?
Yeah.
You don't know.
What do you mean you don't know?
Supposed to be negative.
Slope could be positive and or negative. Oh, that's a problem. We can't have both. So the slope is?
No slope.
There is no slope. It is undefined. It's much easier to say it that way. Undefined slope. There is no number you can associate with the slope because it is going up and it is going down at the exact same time.
That's the one.
I wonder if this will be on the test. If you have y equals -2, how do you graph it?
Horizontal.
It's a horizontal line, and it goes through
-2.
y equals -2, which is down here someplace. So you have -2. And you get a horizontal line going through it. And therefore, y is always equal to -2. If you go over here to x equals 5, how far away is the line? How far is it? 2 down, right? If I go over here to -3, where's the line? 2 down. So this y equals -2 is always a constant. It's a constant y value. All right? Second question. What's the slope of this line? 0. And this is a value. It's just saying it's not positive, it's not negative, it's just kind of going flat, horizontal. All right, so those are 2 equations of lines you need to know. You also need to know how to describe their slopes. You also need to know how to graph them, because I will ask. Now, on the test, I'm not going to ask both of them. I'm only going to ask one. So if I ask you for x equals 3, you have to realize what kind of graph it is. You can't just guess. Guessing won't get you anywhere. You really need to know how to graph those. They do become important later on. All right. More importantly, I hate this equation. Slope-intercept form. And the only reason I hate it is you've been taught it since like 9th grade, 8th grade, 9th grade, somewhere in there. And most of the time your teachers would just give you the formula and you'd go on your merry way trusting exactly what they tell you. Kind of like, why can't you divide by 0? You just take their word for it. So the form looks like this. Y equals mx plus b. And then the teacher tells you b is the y-intercept and m is the slope. And you went, okay. Right? Did anybody ever tell you why m is the slope and b is the intercept?
Not important.
Not important. So what I want to do is I want to prove it real quick. Simple proof. Prove b is the y-intercept. How do I prove b is the y-intercept? Well, how do you find a y-intercept? It's already solved for y.
It's where it crosses.
How do you find a y-intercept?
Make x 0.
Make x equal to 0. So let x equals 0 and see what happens. If you let x equal 0, you get y equals m times 0 plus b. Just like finding a regular old y-intercept. What's m times 0?
0.
What's 0 plus b?
B.
B. So you get y equals b. What coordinate are we talking about here? 0, comma b, which is exactly a y-intercept. Now, I'm not sure how the computer's going to ask you, but if I ask you on a test, what is the y-intercept of a line? Do not tell me b. Do not tell me y equals b, because y equals b is a horizontal line. You need to tell me 0, comma b. Now, the computer will probably just ask you for b, but for my purposes, if you're asked a coordinate on a piece of graph paper, it has to have an x-coordinate and a y-coordinate, and x-intercept and y-intercept are coordinates. That's the way I like you to answer them. All right, now how do I prove that m is a slope? That's a little harder. I have to prove that m is the slope of a line in the form y equals mx plus b. How do you find the slope of a line?
y2 minus
The formula. So we're going to start off with y2 minus y1 over x2 minus x1. All right. And I want to prove that m is the slope of this line. To use this formula, what do you need?
2 sets of coordinates.
2 sets of coordinates. I have one. 0b is on this line, so 0b is 1 point. All I need is one more. Well, how do I find another point? I know. Make a table. So we're going to set up a little table over here. It's not going to be very long. Here's x, here's y, here's mx plus b. Pick a point for x. 1 is just one answer out of how many? An infinite number of possibilities. I want to choose any number. So what should I put there?
0.
Which is, how do you put any number in a position? What do you pick? Yeah, but how do you pick it? What did you say?
0.
No. How do you, I mean, you've been doing algebra for how long? How do you choose a value that represents anything? How do you choose a value that represents anything?
You said a number.
No, you shouldn't be. How do you say in a problem, I want to pick a number, but I don't know what it is?
You guess.
A what? A variable. So pick a variable. You can't use x, you can't use y, you can't use m, you can't use b, so pick another one.
A.
What?
A.
A. Capital A, let's go with that. Capital A. Now, if you pick capital A and you plug it in, you're going to get m times A plus b. Well, what's your y coordinate then? erased it already. B.
Would it be M plus B?
Maybe. MA plus B. Your y coordinate is MA plus B. Whatever the heck this number is. The whole point of algebra is variables represent numbers. Therefore, MA plus B is just a
Representation of the number.
a single number, a representation of a single number. So we have another coordinate. It is called capital A, comma, MA plus B. Algebra is the representation of a single number. As expressions can get as long as they want, but it always represents a single number. For instance, if I read the square root of x squared minus 9x plus 4 divided by x cubed plus 7x minus 5, that represents a number, a single number. Because once you plug x in, you're going to calculate it out, and it boils down to a number. That's what algebra is all about. All right, so now I got to plug it into this formula. I highly suggest go ugly to nice in the formula. So subtract the y's. You get MA plus B as your first y coordinate, so that's y2, minus B, that's your other y coordinate, over, what's the bottom become? Go the right order. I went this minus this, so A minus 0. Technically it wouldn't, well, yeah, it wouldn't matter. All right, what happens on the top? The B's cancel out, and you're left with M, capital A, over A. What happens to the A's? They cancel out, and you're left with N. So we started with y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Where did we end? M. So when I say m is equal to the slope, I really mean it. It is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So now we have b is the y-intercept, 0b, and m is the slope. Another way of reading this is change in y over change in x. When you make change, you go to the grocery store and you buy a $5 candy bar and you give them 20 bucks. What do they give you? 15. What's that 15 called though? Change. So when I say change in y, change in x, it means subtract. It means subtract. Just trying to get used to the language of this junk. Now, this equation, y equals mx plus b, technically only has one use. Y equals mx plus. This formula is usually used to graph a line. Graph a line. There are other equations that deal with separate parts of lines. For instance, do you remember what this one was called? Where this one is slope-intercept?
That's the standard.
This is standard. Standard form is useful for solving systems of equations, but we're not getting there. So slope-intercept is really good for graphing a line. So what we have to talk about now is how do you graph a line without plotting a table? Without plotting a table. All right. So, example. Looks like a word problem, but it's really not. Given that the point negative 3, 2 is on a line whose slope is 2/3, you should be able to graph the line. The rise over line. And it doesn't matter, well, let me ask this question. How many lines have a slope of 2/3? Any parallel line would have a slope of 2/3, so there's an infinite number of possible lines. So once I fix a point, negative 3, 2, we're boiling all those infinite lines down to just one unique one, which is kind of cool if you think about it. So I need a few points, or a few slashes out here. Let's just go 5 in every direction. And before you touch slope, here's where people make mistakes. They concentrate so much on the slope that they start using the slope to plot a point. Slope does not plot a point. Slope is a general indication of how steep a line is, if it's positive slope, if it's negative slope, and that type of thing. So you always start with a point, never with a slope. You need a location before you start moving from that location. So we're going to go to negative 3, 2, which is 3 to the left and 2 up. Plot a point. The line is going to go through this point, guaranteed without a doubt. Has to. When we do rise over run, for the slope 2/3, this marker's dying. This one's dying too. Rise over run. I like rise over run except for one problem. When things become negative, it's not rise over run anymore, so you have to be a little bit cautious with it. I'd rather say change in y over change in x. I think it makes a little bit more sense. And this way, you understand what happens when negatives get involved. When you have a negative involved and you say change in y, which direction are you going to go? Specifically if it's negative. Down, because a change in y would be negative, but then your change in x would still be positive, because you can't have a negative over a negative, because that would make a positive, and you're actually changing the value. And that's where most people make their mistakes. So here we are at our point. Our change in y is 2. So where do I go? Up 2. It's positive. Now those are not points on the graph. I'm just indicating that I moved up 2. The run, or the change in x, is positive 3. So where do I go? Because on the right is positive on the x. So you're going to go 1, 2, wow, this one lands right here. After you move up and over, that's when you plot your other point. You don't plot any point straight up. It's always 2 motions, up and over, or down and back, or down and over, or up and back are the possibilities. Now, this gives you 2 points on the line, but I always suggest you use 3. Number 1, it checks it. Number 2, it makes a better line when you try to draw it. If you try to draw a line between 2 points, it doesn't usually work out really well, except on the computer. I have a problem. If I go up 2, I'm off my graph. So what's another possibility?
Goes down 2 to left 3.
Go down 2, so you go 1, 2, and then left 3. So I'd land right about here. What's the coordinate of this point?
Negative 6.
Negative 6, 0. And this point here, of course, is... I'm not going to write that down. 0, 4. Remember, those are the 2 hardest ones. Intercepts. X-intercept, negative 6, 0. Y-intercept is 0, 4. And then draw your line. And there you go. So to graph a line, all you need is a point and a slope. Now what's nice about Slope-Intercept is it gives you a point, it's the intercept, and it gives you the slope, so you can always use it to graph, well, lines. All right. So let's try this. Y equals negative 2x plus 3. You might as well get used to it. Separate out what the slope is equal to, separate out what the y-intercept is equal to. So what is the slope of this line? Negative 2. I highly suggest you write it as negative 2 over 1. So you can see the change in y and you can see the change in x. You need 2 different numbers. All right, what's the y-intercept? 0, comma 3, because it is on the y-axis. Biggest mistake people make now is they plot this point 3 to the right, because their focus is on the 3. But it's 0 left and right, and it's up 3, so be really careful of that. So, oh, this is horrible, but that's okay. 1, 2, 3, 4, 5. 2, 3, 4, 5. 5. So you plot 0, 3. Where's 0, 3?
Down, I mean, up.
Someplace. It's up 3. And from here, your change in y is what? -2. So from this point, where do I go? Down 2. Now make sure you don't count where you are. I've seen people do this too. They go 1, and they haven't moved anywhere. So make sure you move off that point. So it's 1, 2, then where? Right one or left one?
Right.
Are you sure?
Yeah.
Good. Right one. All right, and then from this point you can go down 2. Another problem that people have is this line here. For some reason, they don't want to count it. I've seen people skip right over it and go 1, 2, and the point ends up way too low. So make sure you count every space going. And then where do I go?
Right one.
Right one. And these 3 lines should line up rather nicely. Okay. Oh, here's something I'm going to tell you, and you're all going to ignore me. You ready? You're all going to ignore me. I've said this many, many times over my, 11, 12 years here, or whatever it is. I always say this. What kind of slope does this line have? Negative. What kind of slope does this graph have? Negative. Make sure they're exactly the same. I've had more people have a negative slope up here and graph this way, a positive slope, because they go down 2 and back 1, or they do something backwards. Be really careful that you lastly check that the slope is negative, the graph is negative. If the slope is positive, the graph better have positive slope too. Make sure they correspond, because that will correct half of your mistakes. But no one's going to listen to me. I wish they would. So that's how you graph a line. Nothing changes from that. Separate your numbers, your slope, into 2 separate numbers. Always write your y-intercept as 0, 3. Plot your point first, and then run your slope, change in y over change in x. All right, the next little topic in this section. Oh, I know what's going to happen. Tomorrow in the lab, you're all going to be like, how do you do this? That's okay. I expect it. It looks easy now, and you're all going to fall apart later. The next one is somewhat more important. It's called Pointslope Form. This is where you find equations of lines. So you're given some information, and from that information you generate an equation, like in terms of slope-intercept usually, or standard form. Oh, I better look. They might go into standard form. Yep, they go into standard form, so we'll have to follow their lead. How this works? Well, we know this equation. We proved it just a little while ago. That y2 minus y1 over x2 minus x1. That gets really boring saying all of the formula. Change in y over change in x. A little quicker. The change in y over change in x is equal to m, and both of them represent slope. All right. Here comes the hard part. Given m and x1, y1. Now what I'm saying here is m is a number, 2/3, 5, whatever it is a strict number. And x1, y1 is a strict point. And like the graphing, as long as you have a point and a slope, you define a single, unique line. So this right here defines a line. How many points are on this line?
Not too.
Only 2 points on the line? How many is a lot?
Infinite.
An infinite amount of points. So what I'm going to do is, this is a fixed point, this is a fixed number, but x2 and y2 can be an infinite number of coordinates. Now, if they're going to represent an infinite number of coordinates, I don't want to leave it as y2 and x2. So what I'm going to do is change it into y and x. And these x's and y's here are infinite points. They represent all the points that have the slope of m, therefore they are all on the same line. So we're talking about all these other points that could be on this line that share the same point with any other given point on the line. Okay. But one thing I don't like about this equation right now is, well, it's a fraction. So how do I get it out of fraction form? Multiply both sides by
It's inverse.
the common denominator, which is
What?
x minus,
No.
what's in the denominator?
X minus
X minus x1. So if I multiply that on both sides, what you're going to get is y minus y sub 1 equals m times x minus x sub 1. And there's your point-slope form. Point-slope form. Where x1, y1 is your point, and m is slope. So if you're given a point and a slope, you can find the equation of a line. Sounds reasonable. For instance, given a point, negative 3, 5 is some point on a line whose slope is negative 2. I want to find the equation of a line. Now, some teachers have taught you how to do that with y equals mx plus b, but the problem with y equals mx plus b is it's a two-step process. And most students don't like two-step processes. They'd rather just get the answer and be done with it. So that's what's nice about this formula. If you use y minus y sub 1 equals m times x minus x sub 1. Anytime you use a formula, don't look at the book and write your numbers on your paper. Write the formula on your paper, because why? Anybody? 2 reasons. Number 1, you know where to plug things in. Number 2, you have to memorize this formula. And the best way to memorize a formula is to copy it down every time you use it, and eventually you'll remember it. It'll get stuck in your head. So on test day, I'm going to give you the question. You're not going to have the formula. You'll have to remember that on your own. So this is one that you have to memorize. All right, so y is a variable. Leave it alone. Y sub 1 is what? It's this 5. It's the y coordinate of the point. So it's going to be minus 5 is equal to, m represents negative 2. And then you get x minus negative 3. So if you do x minus a negative 3, that turns into plus 3. I like doing minus negative. That way it automatically turns into a plus. All right, so here's your equation, which is perfectly fine, but the book wants it in standard form. And remember, standard form is ax plus by. Ax plus by is equal to c, where a, b, and c are whole numbers. So what do I need to do to get this in standard form? Distribute. So you're going to get y minus 5 is equal to negative 2x minus 6. Then what? Concentrate on the variables first. add 2x. You want the x's and y's on the same side. So you'll have 2x, a positive y, negative 5, and it's equal to negative 6. Don't lose your signs. And then finally,
Add the 5.
add the 5. So you're going to get 2x plus y is equal to negative 1. And this is the standard form equation of this line. Personally, I prefer slope-intercept form, but the book is going to ask you for standard form, so you might as well get used to it. That's not that hard, right? Kind of easy. No. So let's try one that has like fractions. See what we do there. Let's put 2 into 1. Example. Find equation of line perpendicular to 3y minus 5x equals 7. That goes through negative 2, 5.
Negative 2.
Oh, yeah, negative 2, 5. Maybe I should make it 2, negative 5. Let's do 2, negative 5. 2, negative 5. Yeah, because I had a negative in the first one. Okay. Now I'm kind of balling a couple ideas together. What ideas am I putting together? Well, here's an equation of a line. It's kind of in standard form, not exactly. And I need to find the line that is perpendicular. So I'm trying to ask you what's the relationship between regular slope and perpendicular slope. So what should I do first? Well, if you're looking for an equation of a line using this formula, you need a point and you need a slope. Do I have a point?
Yes.
Yeah, I have a point. Do I have a slope? No. So I have to go looking for my slope. So where is it going to come from?
You give it to us.
I gave it to you. It's here. You just have to find it. What do you have to do?
Another tutor.
What's that?
Can you get it from the other thing?
I can get it somewhat from this other equation. What do I have to do to this equation? No?
Simplify.
No? It's already simplified.
Get it in
Which formula?
the slope-intercept.
Slope-intercept form. So how do I get that in slope-intercept form?
Add 5.
When in doubt,
Solve for y.
solve for y. So we're going to take 3y minus 5x equals 7. I want directions, not pieces. And how do I solve for y? Add 5x. So you're going to go 3y equals 5x plus 7. Then what? Divide by 3, everything. So you're going to get y equals 5/3 x plus, oh, I couldn't hear that. 7/3. All right. What am I interested in this equation? And the slope here is 5/3. Not the x. Don't ever say 5/3 x because that's not slope. That's still a line. So the slope here, m, is equal to 5/3. Is that the slope I want? I want a perpendicular slope. And the way I indicate it is m perpendicular. To distinguish it from regular old m up here. So what is the perpendicular slope of 5/3? Negative 3/5. So now I have a slope that I have to use, and this point up here that I have to use. And now we can find the equation. Y minus y sub 1 equals m times x minus x sub 1. And plug in all your information. Do I plug in anything in for y? This y?
No.
No, leave it alone. Y minus It's going to be plus. It'll be minus a negative 5 is equal to m. Make sure you pick the one that you want, which is the perpendicular one. So it'll be negative 3 over 5. Do I substitute anything for x? This x? No. Leave it alone, and you're going to get minus that 2 that's over there. Okay. So, now what? You can. What am I going to do? I don't like fractions. I'm going to multiply by 5. So I'm going to take this side, multiply it by 5. Where do I have to multiply by 5 on the other side? No. Just the 3/5. That takes care of the entire side because it's going to eventually distribute over those parentheses. All right, so on the left, you're going to get 5y plus
25.
plus 10. 25 is equal to
Negative 3x.
negative 3 times x minus 2. Stop doing 2 steps in your head. And then what do I do with that negative 3? Distribute. So you're going to get 5y plus 25 is equal to negative 3x plus 6. See, if you do it in your head, I guarantee you to have a minus 6 there.
9 plus 6.
Now what? Get all the variables on one side, so this will be positive 3x plus 5y. What can I do with that 25? Subtract it, so 6 minus 25, negative 19. So this will be equal negative 19. And there's your equation. Now, some standard forms are very strict in the sense that they have to have the x coefficient positive. So if this turned out to be negative 3x, what could you do to the whole equation? You just change all the signs straight across. Multiply by negative 1, it would change all the signs. I think it's time. Ooh, it's getting close though. Trick 1. Find equation of line parallel to y-axis and passes through negative 4, negative 1. Find the equation of a line that is parallel to the y-axis and passes through the point negative 4, negative 4, negative 1. Okay, so what do I do? We can figure out a slope. Sure. If you're parallel to the y-axis, what's your slope?
That's 0, right? No, that's undefined.
It's undefined because it's a
Vertical line.
line. So this equation does not work with vertical lines. This works when we have a value for m. This one has no value for m. There is no number for it. So this one has no slope, no m. Can't use, can't spell today, use point slope. So if you can't use point slope to find the equation of this line, how do you find it? There's no formula for this. There's no equation for this. So my suggestion is draw it. Just graph it, see what happens. So let's plot everything we have. The only thing we have is negative 4, negative 1. So we're over here at this point. The line has to go through this point, one way or the other. Which way is the line going? Vertical. And just by this picture, you should be able to tell me what the equation of that line is. More stuff that I say that goes right through one ear and out the other. What axis is it hitting? And where is it hitting it at? Therefore, your equation is x equals -4. Ooh. It's like pulling teeth. I talked about this at the beginning of the class, last class. Vertical lines are x equals. Horizontal lines are y equals. You plot the point, you draw your line, and wherever it hits the axis, that becomes your variable. And where it hits it at becomes your constant. So you get x equals -4. What if you had a line going this way? What would be the equation of this horizontal line going through that point? Well, supposedly going through that point. Well, the slope is 0. It's horizontal. What axis is it? What axis is it hitting? Y. Where is it hitting it at? And that would have an equation of y equals -1. Oh, yes, you'll have one of those on the test too. All right, homework. This is a section that is really, really important. I love graphing, so you're going to see a lot of graphing. So make sure you do all the practice problems in 3-3. All the practice problems, there's only 7 of them. And then on page 149, (1 through 25 odd). 1 through 25 odd. Oh, let's just make it. No, 1 through 25 odd should work. 29, 33, 35, 41, and 43. Everybody get that? 29, 33, 35, 41, and 43.